Okay, let's talk about the volume of prisms. If you hear a little background noise, that's just a fan. Because let's face it, temperature's starting to get a little bit warmer out there right now. All right, so volume of prisms. Volume of a three-dimensional figure is the measure of space it occupies. It is measured in cubic units, be it cubic feet, cubic meters, or cubic inches. So just when I couldn't get you guys to be square and stuff, now I'm trying to get you guys to put cubic units in there. So we'll see how you relate to that one when you remember to put units. All right, let's go to the next slide here. All right, let's talk about the importance of volume here. And let's talk about Kabul here, where they're putting in an extra building in here, which by now is probably already built and put in. But you realize here, you see all that soil, all this soil in here. It had to be moved somewhere. These trucks are going to move that soil somewhere and dump it somewhere. How many of these trucks you need is based on figuring how much soil you're moving. And so this hole, it used to be all soil. Soil occupied a space. Cubic feet or cubic meters, cubic yards of soil had to be moved, had to be excavated. And figuring that stuff out had to be done in advance. You just don't dig a hole without a plan. You just don't think, I think we might need 2 dump trucks. No, you don't do that. You have to do the planning. The real world is about planning. All right, so let's move on to my next slide here. Talk about the different prisms. All right, you may either have a rectangular prism or a triangular prism. Notice how a rectangular prism kind of common here. And if we look back at my picture again, think about this. It's almost rectangular. You can turn that in here. If I showed you a few of the other pictures. Aside from the little ramp where the excavator was going down, the trucks were going down. But again, shapes come in there, right? So we have rectangular prisms, triangular prisms. We got to be able to figure out the volume. How much space is inside each one of these? Okay, let's talk about the volume of a rectangular prism. Well, you're going to have a length, a width, and a height. And to figure out the volume of this shape here, you're going to multiply the length times the width times the height. Oh, excuse me. Take a little sip here. Now, if we talk about the volume of a triangular prism, well, remember, we have a triangle involved here. So all of a sudden, we have to bring in that half the base times the height, now times the length, because we have a triangle, half the base times the height, but because it's a volume of a rectangular triangular prism, we gotta bring this length in. So that's how that one works there. Now, let's talk about an example problem here. So you got this rectangular prism here with a length, a width, and a height. And to figure it out, you had to multiply. 5 times 4 is 20, 20 times 3 is 60. But you just can't leave it at 60. The volume is 60 cubic centimeters because this was centimeters, centimeters, centimeters. Centimeters times centimeters, centimeters squared. Centimeters times centimeter times centimeter is cubic centimeters. All right, and notice how it's a small 3 off the end there. Let's talk about our next one here. All right, triangular prism. Okay, base times height. So they're talking about this base here, this 6 times the 8. 1/2, 6 times 8, because it's a triangle. 6 times 8, 48, 24, times 9, 216. So that's how you work this. Normally you guys don't have too much trouble with volume. When we start talking surface area, it'll be just like the previous problems, you'll have trouble. So, but you should have no trouble with volume. All right. I think that was the last slide. Yep, that was the last slide. Out here.